Okay, welcome to question A1 DB mock exams. Right, we've got a dog kennel with the diametric axis. Alright, draw the axonometric projection of the structure. So diametric means two of the angles are equal, okay, between the axes. The triangle is isosceles. So we're going to label our points in elevation, right? Okay, and 3D, okay, to use as help we can. A, B, C, right? Okay, then D is over there, E, F. So A slash D, B slash E, and C slash F, right? They're the corners of the roof. All right, then, okay, we'll say the walls, G and H, G, H, right? So we'll get some of these in plan now. A, B, C, D, E, F, then G, and H where the hidden detail is. Alright, now, so we're going to project these points up from plan. So we're going to project A up, okay, G up, B up, okay, D is done. Okay, they are at the inside there. We're not going to do that yet. E and F. Now, I'm going to project those same points down from elevation, parallel to the z-axis. Right, so I'm going parallel to the z-axis. So I'm going down from A to touch point A. I'm going down from B to touch, okay, the projection line coming up from B. I'm going down from C, then to touch the projection line coming up from C, which, sorry, I didn't draw in. So I'll draw that in now. Okay, now, so A, B, C. Then we have F here. Okay, E. We're not going to see D. Alright, now, I'm going to join them together. So A to B, B to C, okay, B to E, F to C, and F to E. Okay, now, let's do, alright, the front here. So we have G and G brought up, and then I'm going to bring H up, and I'm going to bring G and H down. Now, so I'm going parallel to the z-axis, so I'm going to bring G down. So that's point G there, and I have H there. Coming down now here. So that's point H. Right, I'm going to join them together. Okay, now, they're going up to touch the roof. So I'm going to project them up to touch the roof. Okay, then, let's get the right hand side. So, then, all we have to do now, okay, we have a projection line coming down from H. We have to get the back of it. So, I. There's point I. There's point I. So I'm projecting, okay, up parallel to the y-axis. So there's point I. And then we can heavy that in. Now, so let's do the doorway. Alright, now, this is an annoying one. No distance for the inside of the doorway in plan. Look, you can transfer this measurement with your compass down to here. It's too small. Waste of time. Alright, project parallel to the z-axis to touch the base there. Likewise here. Touch there. Now, project these two, okay, the 2 points before the curve starts, down as well. Then we're going to project up parallel to the y-axis there from the door, okay, the insides of the doorway that we've just brought down from elevation. So there we go. Now, here's the tricky part now, doing the curve, right? Okay, 60-30, not really going to work here. There's not enough distance. So the best way to do this is ordinates. Okay, so we're going to draw some vertical lines. Alright, so we'll say 10, 15, okay, and 20. So 10, 15, and 20. Right, now, we're going to put them in plan as well. So we went in from here, 10, 15, okay, and 20. And then I'm going to get another one as well, just here, okay, underneath at the center point. So I'm going to take one up there. Don't worry that they're not, okay, that it didn't go symmetrical, as in that there's 2 points there and 1 point there. I wouldn't get overly worried about that. Okay, it's a small question, you'll get it done right. Now, so we're going to project these up, now parallel to the edge of the end vertical plane there, so that side of the triangle. So we're going to project them up. Then we're going to, okay, so we're going to label these 0, 1, 2, 3, 4, 5, right? It's one of them there that's there, number 2. There we go. 1, 2, 3, 4, 5. Or 0, 1, 2, 3, 4, 5. Now, so this is 0 here by G. 1, 2, 3, 4, and 5 there by H. Now you have 0 and you have 5 done. So then we're going to project these points down parallel to the z-axis and these points, okay, up parallel to the y-axis. So I'm going to do one at a time. So I'm going to bring one up. Then I'm going to bring 2 up, or sorry, 1 down. So I'm going to bring 1 down. So there's point number 1. Okay, then I'm going to bring 2 down. I'm going to bring 2 up. Here we go. Bring 3 down. Okay, and I'm going to speed it up now. I'm going to do 3 and 4 together. Then I'm going to bring 3 up. I'm going to bring 4 up. And then we're going to mark them in. Now I'm also going to see, alright, the inside there. Okay, now I'm going to untape my sheet and I'm going to freehand sketch this in. Right, so I'm going to pause. Now, so that's the curve done, right? Part B, beautiful question this. In the axonometric view, show the projections of the line of intersection between surface A and the horizontal plane. Okay, the extension of surface A. The horizontal plane. So if I do this in 3D, if I extend surface A, there on about where it touches the horizontal plane, drawing the line of intersection. The only way you can find the line of intersection is that both surfaces project as an edge in the same view. Now here's the horizontal plane as an edge right there. Here's surface A as an edge. So, what we have to do, okay, is continue this. Now don't worry if this runs on to the next question. Don't worry about that. And then we're going to run this down here. Now, this is a point view, the line of intersection. Then, we're going to project, okay, this back. So we're going to project this back, and here is our line of intersection right there. Okay, there's our line of intersection right there. So you could call that the H. It's a HT. Now, another way that you could do it, right, is to note this is the vertical plane here when the plan is set up as shown. Here's the horizontal plane. So back, okay, the XY line is also there. So this is some of the horizontal plane. This is some of the vertical plane. Here's technically our XY line. Now, the back of the surface, A, is on the vertical plane in plan. So this is on the touching the vertical plane. Now, if you extended this line down, so if you extended E to F down, it's going, okay, that's technically the VT. Alright, and because, alright, this line is a point view, alright, the HT, okay, this line is a point view in elevation, okay, it's a true length, okay, and it's parallel to the horizontal plane. Our HT is parallel to this as well. Because it's also parallel, okay, to this plane here, the end vertical plane. So likewise, this will be another way. Then you continue that down, draw a line parallel to it. Lovely question.